linear functions. Remember, this idea of a linear function is just a graph that makes a straight line. And we're going to be able to graph these just by plugging in zeros for x and y's and just simplifying and doing a little bit of solving. So it's called graphing in standard form. And why that is because we kind of have slope-intercept form that y equals mx plus b. And standard form is just another way to write that same thing, but it just looks different. So this first bullet point in our definition box is what standard form looks like. This ax plus by is equal to c. Those capital letters A, B, and C, those stand for different numbers. And then where x is still kind of your input and y is your input. And kind of one thing we have to say is that A and B both can't be 0. So like A could be 2, so it could be like 2x plus 3y is equal to 6. That would be an example of something in standard form. We'll practice later on how we can make that look like y equals mx plus b by moving things around. But today we're just working with it when it looks like that. And what we're going to do with this is we're going to graph what we call our x and y intercepts. So I'm going to do this up on just the whiteboard here. I think it's easier to see. So we have a plane. Like when you fly, you call this a coordinate plane. This is our x-axis. This is our y-axis. And we have a line, let's just say it goes from there to there. And it crosses our two axes at two different points. It crosses kind of our y-axis right here and our x-axis right here. And those 2 points have specific names. This is called the x-intercept. An intercept is just a fancy word for a point where something crosses. So you think like an interception is football, that's when the possession crosses over to the other team. Same idea here, x-intercept. This, since it's on the y-axis, is called our y-intercept. And kind of why these points are useful is because for our x-intercept, we know it's always going to look like, since this is going to be a number. We count like however many grid lines is across. So our first point are going to be a number. It could be any number. But since we haven't gone up or down at all, we're just kind of even. We always know our y value is going to be 0. And this is going to help us, and you'll see why in a little bit. And this one is the opposite, the y-intercept. We have to go down a certain number of tick marks, but we haven't gone left to right at all. We're kind of dead center. So now our x value is 0. We're drawing a point. And our y value is a certain number. So that's what the next 2 bullet points, or is it just the first bullet? Yeah, the next 2 bullet points are kind of trying to explain. I think it's sometimes hard to take math and long sentences and put it into, okay, how am I actually going to use this? But, so the x-intercept of the graphs, what we were talking about here, is the x-coordinate of the point where the line crosses the x-axis. So this is our x-coordinate, whatever this number would be, and this would be together. The point is our x-intercept. Same thing for y, what that second bullet point is getting at. So what we're going to be doing is, since this is 0 and this is 0, we can plug in zeros for x and y into our standard form to find these 2 numbers, is basically what we're going to be doing. So for the first example, example 1a, 3x plus 4y is equal to 12. That's kind of our standard form here, where a, in this case, 3 is our a. This could be like where our b is, and this is our c. Again, all those just stand for numbers. And this is going to take 2 steps, and then we're just going to have to graph it. First step you're always going to do is you're going to plug in, or I learned yesterday that some of you prefer the word substitute. That makes more sense. So we're going to say sub in 0 for x. That's kind of your first step. So what that'll look like, we write 3, then instead of writing an x, we substitute in a 0, and then we just copy else everything that we have. So we have 3 times 0 plus 4y is equal to 12. And now we're going to simplify, then we'll have to do just one step to get y by itself. So we could take 3 times 0, and then any number times 0 is just 0. So this goes away, and we're left with 4y is equal to 12. And we know whenever we have a letter with a number, to get the letter by itself, we got to divide by that number on both sides. So this will be y is equal to 3. So what this is saying is that when we have an input of 0, we get an output of 3. So we can write this as a point. We could say 0, 3. And we can also graph that as well. 0, 3, if this is our x-axis, this is our y-axis. We haven't moved left to right out because we're at 0, but we have to go up 3. 1, 2, 3. And we're right here. Just so we're clear, that's the point 0, 3. So that's our, we just found our y intercept. And we like to abbreviate intercept with just int. So now that's your first step. Your second step is instead of plugging 0 in for x, we're going to plug it in for y. I'm going to say plug 0 in for y. So we'd write 3 times x plus 4 times, now instead of y, we're substituting it with a 0. And that's still equal to 12. Now we do the same thing. We simplify, and we got to figure out what x is exactly. 4 times 0 is going to be 0, so this goes away. And we're left with 3x is equal to 12. And again, we just have to do a little bit of division to figure out what x is. Divide each side by 3. 3 and 3. So we get x is equal to 4. We do the same thing that we did with our y-intercept. We're going to turn this into a point. But since now that we're given our x value, that's the number that comes first in the parentheses. So remember, coordinates are always written as x comma y. So this is now, if we have an input of 4, we get an output of 0, and that's your x-intercept. And if you want to add like this to help you remind you, this is your x value, that's your y value. This is your x value, that's your y value. So now we just have to graph that point, 4, 0, which means we just go 4 spaces to the right and draw a point. We're going to go 1, 2, 3, 4. We have a point right here. That's the point 4, 0. And if we want to put step 3 in there, we would say draw a line to connect the points. And we want it to be linear. Let's get, so we're just going to try to make as straight of a line as we can. And there's graphing in standard form. So we'll go through this second example. Sometimes I know, you can be like, first example, you're like, wow, Mr. Scully, that's a hell of a lot of detail just went into. I'll kind of write down on the next one, like exactly what you should be doing when you're showing your work and kind of leaving out a lot, kind of like the extra kind of notation and things like that so you don't feel like you're getting bogged down by it. So this one we have 2x minus y is equal to 4. So the first step, like we said last time, is plug in 0 for x. So I'm just going to write 2, and then instead of x, I'm writing parentheses 0 minus y is equal to 4. Simplifying, this goes away. 2 times 0 is 0. So we're left with negative, I'm going to write this negative 1y in front because we don't want a negative 1y. And again, 1's always floating in front of our numbers. We want a positive y. So just like undoing a letter in a variable, we just have to divide by, sorry, I said letter and a variable. Those are the same thing. A number in a variable, we have to divide by that number. So to get y by itself, we have to divide negative 1 on both sides. So our y value is equal to negative 4. And some people don't even like to make like the point like write 0 comma negative 4. If you're good with where to graph things, you could just take this y value of negative 4 and say, okay, well, y goes up and down. If I'm going up, my numbers are positive. Down, my numbers are negative. So if you just think, all right, I'm starting at the center and I go 4 down, 1, 2, 3, 4, I know that's where my y-intercept is going to be. So if you keep consistent and say, okay, I'm always going to plug in 0 for x first. That means you're always finding your y-intercept first. Because this is the point 0 comma negative 4. Right, sometimes doing the same thing, the same process each time with the problem in the same order helps a lot. So again, I'll just kind of write this as 0 comma negative 4. And I said my second step was then to do it with the other variable. Now y is going to be 0 and x is just going to stay x. So we write 2x minus 0 is equal to 4. Oops. So subtracting 0 is not going to do anything to our equation, so we can just cross it out like we were doing the other ones and say 2y is equal to 4. And then divide each side by 2 to get y by itself. Oops, sorry, that should be an x. Change that back to an x. I got too excited. 2x minus 0 is equal to 4 because we already figured out what our y is. We need our x value. So x is equal to 2. So again, you could just think, I know now I'm solving for my x-intercept. I know my x is positive 2. Right is positive, left is negative. So I just count two tick marks over, 1, 2. I know that's where my point should be. So I'm go right there. And now I just need a line through both of my points. And I should be good to go. So this is 2 comma 0. And a linear line through both of them. So plugging in x for 0, you first find your y-intercept. Your second one you always find is your x-intercept. And then step 3 is just to graph. And again, to find your y-intercept, you kind of do the opposite. You plug in zero for x. And to find your x-intercept, you plug in 0 for y. This is the other kind of opposite. To find your y-intercept, you plug in something for x. To find your x-intercept, you plug in something for y. On graphing, just connecting the dots. All right, so last two examples on the bottom are quick. It's just graphing horizontal and vertical lines. Horizontal and vertical lines are a special case because one of them has a slope of 0, the other one has a slope of what we call it's undefined. So there's just a pattern you have to remember when you're graphing these, and it makes it super simple. So I'm not even going to talk about the stuff in the box here. I think I can just explain it better with the diagram. So when y is equal to 2, if you ever have a y equals a number, this is always going to be a horizontal line. Again, horizontal lines are ones that lie flat. So you're always just going to look for the number that it says y is. So y is equal to 2. So that means, again, y goes up and down. So you have to go up 2 and draw a flat line. So this is where y is 2. And we just draw a line through. This is y is equal to 2. Because any point that I choose on this line, my y value is 2. This is 1 comma. This is 1 comma 2. This is 2 comma 2, 3 comma 2, 4 comma 2, 5 comma 2, negative 1 comma 2, negative 2 comma 2. Our second number is always 2. My y value is always 2. So if we're doing a x value, and x equals to a number, that's the opposite. X equal to a number is always a vertical line, so a line that goes up and down. So again, we find the number that x is telling us, negative 2, so that means you have to go 2 to the left, like on a number line. And now we have to go vertical, so we're drawing a line up and down. So negative 2, going up this way, and down that way. Because anywhere on this line, our x value is always negative 2. This is negative 2 comma 1. Negative 2 comma 2, negative 2 comma 5, negative 2 comma negative 3. It always starts with a negative 2. All right. So just doing this second one quick, we can see pretty easily. X is equal to 5. We gotta go over to the left 5. And go up and down because it's vertical. 1, 2, 3, 4, 5. That's x is equal to 5. To get y is equal to negative 3, let's go down 3. And horizontal. So if you can just remember the pattern, x equals is vertical, y equals is horizontal. You just need to then know where your numbers are at on your graph.